Welcome, everyone. I'd like to introduce myself. I'm Glenn Hawkins, Senior Director of Product Management for the Oracle Database team, focused on maximum availability architecture in DataGuard, as well as other high availability components. Today, we'll be focusing on maximizing data uptime, Oracle MAA solution for hyperscaler resiliency. So with that, let's go ahead and jump into it and start with why is resiliency important? So there's a lot of surveys out there. People have gone ahead and done a lot of research into this. The one thing kind of stands out constantly if we look at high availability and the way the world has been impacted by different types of outages is they are common. In this example, you can see we have 94% of respondents have reported at least one outage in the last 12 months. And 60% of those, it involved unrecoverable data. And the cost is fairly high at 250K plus for just a single hour of downtime. This is mostly focused on unexpected outages. Now, the different types of downtime risk exposure can fall into three different categories. We have financial risk, kind of focused on the business interruptions. So your overall business, as the continuity drops, so does your overall revenue. Customer retention is a big part of this, and losing customers that may have been impacted by the unexpected downtime can be fairly costly as well. And of course, the reputation of your brand also ties in with both the financial risk and your customer risk. And finally, from a regulatory standpoint, a lot of businesses, particularly financial, telecoms, different geographical areas, have penalties associated with business continuity problems as well that can result in fines. If we look at the different type of downtime, overall, we've been talking about unplanned outages, but they fall into two categories. We have planned maintenance type events, and then we have the unplanned. Now, planned maintenance is really important when you're looking at downtime because it's much more common than unplanned at the end of the day. This can involve server changes, you have database upgrades, application upgrades, you have migrations, you have infrastructure changes that may occur. A lot of times this is happening on a routine basis. So that's one important aspect of this. And then, of course, to the unplanned side, and we looked at the big numbers associated with that. And they come in a lot of different flavors, right? From a single node computer failure, storage failure. You could have an entire site. We could have some type of natural disaster, such as a power outage that impacts an entire region. And then there's other things that you may not think about, like data corruption, human error, lost rights. And then, of course, the infamous performance basically spiral, where your performance, you start to see it hang, you start to see it slow down, and eventually results in an outage. These are all important aspects that we go ahead and look at when we go ahead and take a look at downtime across the board. Now, how can we go ahead and enable high availability resiliency to avoid this type of downtime? Well, the answer ties in with Oracle's maximum availability architecture, which is a solution at Oracle, not a product. It focuses on a lot of different products, but it comes from customer insights and expert recommendations from our teams working with you guys over the last 25 years. Out of it, we've had four different metal tiers representing bronze, silver, gold, and platinum that represent different downtime expectations as well as your data loss risk tied with each one of those. As we go from bronze to platinum, the risk drops, the downtime is minimized down to basically near zero. And then if we look at the five different categories of the product on the right-hand side there, we see high performance, continuous availability, data protection, active replication, and scale and lifecycle. And some of your favorite products like DataGuard, Rack, Golden Gate, all represented here in these different categories. And many of the different products and features span more than one category, and they're all integrated together. So these features and technology combined with the configuration and operational best practices and our documentation and guidelines is what goes ahead and provides MAA, the reference blueprints that you can go ahead and build on to get the SLAs that you need. And then you have a bunch of different deployment choices from generic systems to engineered systems. We start talking cloud with BaseDB, ExaDB, Autonomous, and all combined into multi-cloud as well, which we'll be focused on today. And to go ahead and get up into the cloud or move into our engineered systems, you can use our zero downtime migration to do so with minimal downtime as well. Now, if we look at these different tiers from a different perspective, we can see the different categories of apps that might fall into these different tiers. It all starts with bronze. It should be pointed out these are hierarchical in nature. So they're all supersets of one another as we go ahead and move up the chain. So bronze is the foundation for everything. It's a single instance restartability. We have a lot of features and functionality that are represented in bronze. If you look at the RTO and RPO at the bottom, you'll see the instance failures. We're looking at minutes to an hour from an instance failure just to go ahead and restart. Disasters that go ahead, such as a power outage, you may have to restore from backup. And also from an RPO standpoint, what is your data loss risk? Well, it's since your last backup. We recommend under 15 minutes at the bronze level. This carries over into silver as we start looking at more mission critical type of applications, more product departmental at this point. We bring in our clustering technology, rack, into the picture. So at this point, we can go ahead and do things like rolling patching from a planned maintenance standpoint. Um, we can go ahead and quickly recover from any type of compute failures that may occur. And from a standpoint of application continuity that ties in with this, we can protect in-flight transactions to make it seamless for the application utilized in the database as we do a role transition. Now, this allows us to go ahead and get an instance failure of under 30 seconds on commodity hardware, and on Exadata, that's single-digit seconds. For disasters, it's still the same because the entire cluster would be impacted. So we're talking hours to days. Same with the data loss risk. We're still go ahead and dependent upon our backups. That all changes with gold as we roll out disaster recovery. This is where mission critical or business critical type of apps are run at the end of the day. You have a primary and you have a secondary site. Active Data Guard comes into the picture, providing that level of protection. And we can see that represented in our RTO and RPO. So for an instance failure, it's exactly the same because rack is going in and protecting us. Same with planned maintenance. We have a rolling patching capability. And then we have, for disasters, we drop down to seconds to 2 minutes. So we can do a very fast roll transition on that front. And our data loss risk has dropped significantly as well from DataGuard going ahead and providing its replication capability to go ahead and protect their data. Finally, we moved to platinum and we combined everything we have in gold with Golden Gate, giving us an active architecture on top of it, which allows us to do application upgrades, as well as many type of planned maintenance activities without taking any downtime associated with that. And we can see that represent our instance failures, our disasters as well, that we have a whole secondary site up and running to give us that near zero RTO. And then we have our RPO of 10 seconds, exactly the same as with gold, because DataGuard and Active DataGuard are still in the picture providing that level of protection. Now, where can you go ahead and utilize MAA? Well, you take advantage of on-premises, right? Of course, with commodity hardware engineered systems in the cloud, as well as multi-cloud for Azure, Google, and AWS. But what does that actually mean, right? And how does MAA do its testing? Well, we use chaos engineering to go. We introduce basically problems and recreate everything from corruptions to downtime to literally pulling cells up Exadata machines to go ahead and test these environments. We start with our generic systems and build up to our engineered systems where more functionality is built in. So we have our full stack on Exadata, for example, that specialized hardware allows us to do role transitions very quickly, as well as to be very standardized. And that carries into the cloud. As we start looking at the Exadata database service running up in the different cloud hyperscalers, we have all those same capabilities, plus the cloud automation that automates all that and standardizes it in the cloud, all the way up to autonomous database where everything is standardized and we're basically doing most of the work for you from a standpoint of resiliency. So let's look at how this might work. We'll look at the journey to resiliency and how it works in the multi-cloud. Starting with the on-premise, we have our commodity hardware. We have an Exadata machine. We made the decision to go ahead and move into multi-cloud. So we're going to go ahead and choose one of the hyperscalers. We'll choose whichever one we might have a relationship with or running our apps in today. Once we made a decision, we can go ahead and use zero downtime migration to go ahead and do a zero downtime migration up into the cloud. Once that's up and running in there, assuming you're on ExaDB, you're already Silver MA. By default, we run rack on Exadata. So when you migrate up there, you have all those capabilities available to you. Well, let's make sure we're taking backups as well. We have the autonomous recovery service, so we can do an incremental forever point-in-time recovery at any point we desire. We can configure that with a single click. And now we can go ahead and run our applications. So we're set up within the region. But what if a power outage occurs? So we want to go ahead and provide a different level of protection for disasters. So we'll go ahead and set up a second region. We get ExaDB up and running. We have our standby database configured with DataGuard. So now we have that capability set up. We could take advantage of the autonomous recovery service over there as well, giving us a second level of redundancy, and take advantage of active data guard, providing another level of protection with app continuity built in, as well as automatic block repair. Active data guard has another benefit as well. Now we can run our reporting applications over there on that standby, so it just doesn't sit idle. We can take advantage of that architecture as well, going to give us more scalability and taking advantage of reporting apps that might be running closer to the second region. All right, let's take a deeper look at the building blocks that make up MAA from a technology standpoint. So the first is RAC. The RAC is our clustering solution. It provides a unique scale everything solution, providing an active instance. So different nodes, we call them, going ahead and running in the architecture. One node goes down for whatever reason, we can easily go ahead and pull up another one. It scales for OLTP, OLAP, hybrid workloads, and you have rolling patching built in. So as we go ahead and patch the database, we can roll from one node to another so we don't experience any downtime. Applications that are already running a single instance Oracle database can easily migrate to Oracle RAC without any changes. So that's an important aspect as well. So it's completely agnostic from that standpoint. And then from a scalability, from elasticity standpoint, you can add and you can remove nodes, right? We can go ahead and take advantage of those, easily scaling out our application or scaling it back down again to meet workload demands. Now let's look at disaster recovery. So we have active data guard in the picture. Active data guard provides in-memory replication to one or more standbys out there. Those standbys, as we noted before, can be used for read-only or read-mostly workloads as well. Active Guard also provides capability to do rolling upgrades, supplementing what you got with RAC with the rolling patching. So you can bring it to upgrades as well. All integrated with our app continuity feature, providing the in-flight transaction protection as well for Active Data Guard, just as you have it for RAC. You can have up to 30 read-write replicas out there, so those read-mostly replicas to offload, providing you a maximum return on your investment. And you have the ability to have synchronous or asynchronous replication, allowing you to go ahead and do so over long distances. We have features like FarSync also to go ahead and provide that additional zero data loss protection over very long distances if you desire that level of protection. Finally, you have a lot of different options for multiple and cascading standby databases as well. A lot of different variations here with the configuration. On ExaDB, you could have up to 6 standbys. And it can be increased even more. So with ExaDB, if we look at MAA Silver load, we'd be looking at this type of architecture. Note that you have the option to have the autonomous recovery service. You can have it running in the hyperscaler region for most of the different hyperscalers, or you can run in the OCI region or both. So you have that option as we look at Silver MAA. So we can go ahead and connect up to the nearby OCI region if we desire to, providing that extra level of protection. And then as we look at Gold, with our cross-regional configuration, we have a bunch of different options with Active Data Guard. You can take advantage of going from availability zone to availability zone with your Data Guard configuration. So autonomous recovery service can be running in each one of those availability zones or in the nearby OCI region. And you can take advantage of the OCI managed network as you want, which is a highly optimized, high throughput, low latency network that you can take advantage of for your Data Guard redo, allowing you to go and easily scale and provide that level of protection. All right, let's go ahead and take a look at the MA certification across the different multi-cloud hyperscalers. First, we'll start with OCI. We have Silver, Gold, Platinum already certified. As we go ahead and look at Azure and Google Cloud, Silver and Gold are already certified against Cross-AD, as well as going ahead and going cross-regional. And with AWS, Silver and Gold are on the way. For all the different hyperscalers, we're also working on Platinum MA, which will be coming in the future. Now, what makes Oracle MAA special at the end of the day? Well, at the core of MAA is RAC and Data Guard. They're very simple and reliable. They've been around for a long time. They're very portable at the end of the day. They can be used across multi-cloud, on-premise, engineered systems. A lot of our MAA best practices apply to all those. The applications remain unchanged as we're going ahead and moving them onto a RAC cluster or taking advantage of Data Guard. Everything's very adaptable. If you have different data centers, depending on the distance and the latency requirements across those different data centers, Active Data Guard has a lot of flexibility and the way you can go ahead and handle your replication. You're continuously connected at the end of the day as during role transitions from either rack or active data guard, and the transparent routing happens under the covers automatically. You can also go ahead and send your read-only traffic easily to your standbys. Finally, the different types of data types and workloads, the Oracle database can handle converged data across all those different types. And with that, the high availability and data protection that we've been talking about there with MAA would apply to all those different data types and workloads as well. To learn more, go ahead and you can check out Oracle Multicloud Solutions. We have use cases, solutions, FAQs up there. We have live labs that you can go get hands-on with Rack, Active Data Guard, and many different HA technologies. And finally, you can drill into our documentation with all our best practices and guidance that we have for everything from data guard tuning to deploying Rack to going ahead and pushing your data and migrating up into the cloud. And with that, I'd like to thank you all for attending.